Relational databases organize information in rows and columns. This makes them perfect for structured data. But they're not optimal when we have to deal with unstructured data such as text, images, video, and audio. To convert multimedia into a format that computers can understand, we use vector embeddings, which are then stored and organized in a vector database. Essentially, in a vector database, we have arrays of numbers clustered together based on their similarity. Let's imagine YouTube's database with millions of videos. These videos can be grouped based on their genre. We can have vlogs, gaming videos, tutorials, how-to videos, tech reviews, music, and other formats. The goal is to index all videos and organize them in a way that allows very fast retrieval and search. To do that, vectors are organized in the database so that videos with similar content are positioned closer together in the vector space. This organization is based on similarity metrics that measure how close or distant the vectors are from each other, which can be interpreted as what is the difference between videos in terms of genre, content, length, or other stylistic similarity. Please consider how much data can be used to train an LLM. In some cases, we can have millions and millions of vector embeddings, which means that querying millions of vectors and looking for similarities would be very slow. To ensure fast retrieval of the data, vector databases rely on indexing and use ML techniques that allow them to search efficiently. The use case of vector databases I described here is about search. We can use vector databases for similarity search and search based on meaning and context of words. In addition, one of the coolest applications of vector databases is giving LLMs like GPT and Gemini long-term memory. By storing past interactions or learned information as vectors, a model can reference this data to better understand context. For example, if you use an LLM as a chatbot assistant, it can store information about previous conversations with you and similar customers, and provide more informed responses. For your AI projects, consider popular vector databases like Pinecone, Weaviate, Milvus, Chroma, and Elasticsearch. While highly popular, Pinecone is not open source, which may limit some projects. In contrast, Weaviate, Milvus, Chroma, and Elasticsearch offer popular open-source alternatives. We'll spend more time discussing open versus closed-end AI tools in our next session. Thanks for watching.